Hello. Hey, welcome back. It's been maybe quite a while. Thankfully, it hasn't been super long time, but um, I was able to kind of go through and make another video about another pattern in Typescript, the Decorator pattern. And this pattern took me a little bit of time to kind of figure out what are some practical ways of applying this pattern in maybe an application or software or for some specific purpose, because there's a lot of examples, literature, videos, a lot of things online that kind of connect it to maybe the analogy of like using food or making a pizza or making a drink. But I don't think that really is a good way to kind of understand how this pattern can be used in an actual real life application or program. So I found an example that I think is useful. And before I just jump into the code, jump into the program, jump into the application, I did want to highlight two important concepts when it comes to this specific pattern. So I think the first thing that's very important is understanding that this pattern kind of highlights the open close principle in terms of the solid principles for maybe clean code, all of that. And that principle specifically focuses on having some design or something in your code that is open for extension but closed for modification. And that kind of means you're able to kind of add on to your code without having to kind of hard code and change the base parts of your code. Another thing that I think it's really important to consider is that this pattern allows you to dynamically change maybe some base component or some base class, or maybe some concrete implementation of some class dynamically at runtime. And so maybe you have some purpose in your function or in your code that you're constantly needing to change something for the user. And so this design pattern can be useful for that purpose as well. So I'm going to try and highlight a bit of those concepts and try and explain a little bit more of the design pattern while giving an actual life example. So, all right, so here we go. Okay, so just looking at this, let's pretend this is a video game or some software that has this specific screen where you have these weapons. And let's pretend that there are several different types of weapons. There's swords, there are clubs, there's shurikens. I don't know. You guys can think of maybe many different types of weapons. And usually in these video games, there's a screen where you can kind of upgrade or update or kind of add modifications to your weapons, maybe through like some blacksmith or through some other way you can add on to your damage or modifier or special. And so we have these different options on the screen, and we have a specific amount of coins, so we can upgrade the damage. And then as you can see, once we've upgraded the damage, we are not able to choose the other ones, or we can kind of add on modifications like now we're adding on like specials like poison, ice, fire. You know, we're able to kind of do that. We're also maybe able to add on like something like special, like I clicked it, it became sharp. I clicked it twice. Now you can see it's like it's sharp and delicate. So there's a lot of different ways we can code this, because if we think about maybe weapons as only being maybe two weapons, like maybe let's say we had only a sword and a club and we're only adding on these three upgrades to those specific concrete implementations, that's not too difficult. But what if we wanted to have some design in our coder application? We wanted to kind of expand out to have the ability to add on as many different weapons as we can. Let's say this was an online game and we're constantly wanting to update the weapons by adding maybe new base weapons. Maybe you want to add something like a katana or a bow or a gun. And let's say, for example, maybe we also at the same time want to add on maybe even more updates or upgrades. Maybe let's say we want to add on 2 new attributes that maybe you can update to the weapons. Let's say you want to be able to add maybe long range, or maybe add on a different property. So once you add on those different attributes and those modifications, then you kind of see that it becomes a little bit more difficult in being able to dynamically change for the user, but at the same time create a design in your code to being able to expand out your weapons, and also at the same time expand out your upgrades and your modifications. And so how can we kind of code that out? So with this pattern, we first have to kind of have some base class or base component that we're focusing on. So we are focusing on these weapons that we have created, and so there are kind of 2 different ways that we're concrete implementing that weapon. And another important thing to kind of consider with this specific pattern is that we are replacing a lot of our setters. So typically when we have these classes, we're going to have getters and setters, but we're only going to focus on getters with our interface and the way that we implement these classes, because the way that we set these attributes are actually with these decorators. So we have this base class interface. We have the concrete implementation, the way that we're kind of going to continuously modify these base classes, base attributes, by using something that we call a decorator. And an important part of using these decorators is understanding that they're not an interface, but they're actually an abstract class. And why the difference between the two: when you have an abstract class, you're forcing a hierarchy, you're forcing an inheritance pattern where every child will inherit from the parent. So when you force that model onto the base class, you can kind of create this, a lot of people say onion, or you can think of it as like a chain, because every child is kind of connected to the parent. You can modify the getters and the attributes by, in a sense, every time you have that decorator, you're modifying or changing it slightly in the child. And every time it's instantiated, it will have that base class, or it will have some implementation of that interface or of that class to modify. Okay, not gonna lie, that might have been a little bit complicated and maybe a little bit convoluted to understand. So I did want to highlight the 3 different ways that I implemented the decorators. So this one is focused on the damage, this one is focused on the special, and this is focused on the modifying for the decorators. So these actually implement this decorator, which in a sense will have the weapon as well. So we have to really understand this kind of way that this pattern is being placed. So there is something like a base component that has an interface that we want to focus on the abstraction here. And then there's decorators that are decorating around that interface that will implement that interface, but will be an abstract class to force the inheritance model, where every decorator will have that weapon class inside of itself. And through this model, we can continuously wrap more and more and more of these classes together. And so as we wrap these classes together, we can modify and change slightly. Like, for example, in this damage upgrade decorator, every time it's created and instantiated, when it gets called, the get damage will add 50. Now, if we think about this decorator, if I go into, so I have this update damage. So you see here, the sword is just, it's a sword. It's instantiating the physical concrete implementation of the interface. And so every time this button gets clicked, it's going to wrap that sword or that weapon into this class. If you think about it that way, the class or the abstraction is still technically a weapon, but this time when the get damage method is being called upon the sword, now it's being called on this one and that one together. And so it's chaining the get damage from the original interface. And so because we're wrapping it, it's chaining these all together as they're getting wrapped and wrapped and wrapped around each other. And every time they get wrapped with each other, you're adding 50. So if we go back to our code, that's how we kind of gone 0 to 50, 0 to 100, 0 to 150, and then 0 to 200. Through that, through the chain of wrapping around each other. And what's very nice about these decorators is that you can modify it not just to add damage, but you can add conditionals. Like this one, I added a conditional where if the class it's wrapping around doesn't have anything at all, then we can add on this modifier. And so just to show you, if I do it for the first time, it's going to have that sharp. It's going to add that. I do it again, it's going to add sharp and delicate. And so that's one way we can add on to these decorators. Maybe have conditionals, switch statements. We can also, for this one, for the modifier, I have a specific array at the top, like a global array for the mod array. And every time it gets called, it's going to like randomly choose a modifier. It's going to like have the damage. If the damage is greater than 0, it's going to, whoops, that's not meant to be. Okay, sorry. That's not meant to happen. If the modifier is greater than 0, then it's going to just multiply that with the damage, add it to the mod damage. If it's not, then it's just going to be 0.5. And so you can kind of see that in action. So you see it's 0, 0. It's just going to add that. When I upgrade, it's just going to do that. And so, again, what's really nice about this design pattern is that we can add as many weapons as we want because this is an abstract. We're coding to the abstraction with the interface. So in case we want to have a club or a sword, the base attribute want to be different, you could do that. Maybe the special, it's already going to have a special. Maybe you want to already preset it to have a specific mod. And for the decorators within the class, maybe you want to add on more modifiers or more things. And adding on to the abstraction, the interface is a lot easier as well because you create consistency in all of the base components and the base classes, and it's you're forcing a specific way that every weapon should be coded. So even if, let's say, for example, maybe there's some weapon that shouldn't have any damage, um, even if it doesn't have damage, you're still forcing it to maybe you're forcing it to follow this pattern. And at the same time, maybe in the future, if you had some decorator, it wouldn't be it would still affect that weapon. I hope that made sense. Um, Another key thing to understand about this design pattern is that it might not apply to all your programs or your functions. It took me a long time to even consider using this game analogy because that was the only one I can think of that I felt like would demonstrate this pattern. But there's a lot of other ways that you could possibly use this, but I think it's more so thinking along lines of you're wanting to expand something that you're going to have to continuously modify in your application. And that might not apply for all cases. So the very last thing I did want to specifically talk about, and I might just include it in the README, is the real life application of this design pattern, because it is really tough to think about, okay, I'm not going to really have a user dynamically change this whatever I have in my program at runtime, or I don't really see a necessary need for this specific pattern. And I think that's perfectly fine, because there might not be a lot of times where you have some class where you're trying to have like an enormous amount of different choices in that implementation, or you're trying to have a lot of ways that you're trying to modify it. Like the biggest example I've found was, Java, the streams, like file streams, are able to be modified through not at runtime, but when you're pulling information from a file, maybe you're trying to continuously change that type or modify the way the file is being outputted. And so that's one example that Java uses the decorator pattern to create or implement the file streams. And so you can look that up on their API. Another big thing I've read is also using like views. I've coded before in Android Studios, so there's a lot of different views that, like the adapter views, stuff like that, where you're adding on to this view, text view, and you might be adding on like a scroll bar or adding on different modifiers on top of some base view that maybe is like just text, or maybe this is just a screen, or like, I don't know if many of you have used like JavaFX or some front end library or Vaden. Maybe in that same manner, you're trying to create some program or some application where you have some base screen, and that you're constantly going to be adding on some attributes to the screen, or you want to be able to add on or remove and add on more and more different parts of that screen. Like this part of the screen is just for text. This part of the screen is just for the pictures, and every part of that screen is modifiable. And so that's another way that you can use it. But I really wanted to just include this code and this and just like the HTML, just to kind of maybe help visualize and show, and definitely help maybe people out there that are a little bit lost in the sauce about figuring out like how they can use this pattern or create it. And so the last thing I will say is the abstract class is necessary for this pattern to create. A lot of people say an onion. It's in a way like a it's like a tree almost, or it's like a linked list of inheriting from each one. And the methods are also the most important thing is the methods are being chained every time. So it's you don't need the setter because the way that you've coded it in that sort of chain is that every time it's calling on each one, and every time those things are being called, they are changing it in some significant way or some small way. And so at the end of that chain, or at the end of that hierarchy, that will output the total or whatever you wanted it to be modified as. So it is something to consider, that you have to kind of consider it in the way of that chain. It's not something that's might be modified like it's there or it's not. Because if you think about it in that binary way, maybe you're going to have to code in that way too, of okay, it's this has it, then the child, it got wrapped around that, it didn't have it. So just try it, just practice. I think that's also a good thing too. So that's about it. But thank you for watching. If you liked the video, like, subscribe, whatever. And hopefully I'll have another design pattern out soon. So you can check the code in the GitHub, and I will have updated the README. I will update the README with further notes that I have written down. So hopefully that will help you guys. Thank you.